Hello friends, today in this video we are going to solve another interview problem, that is minimum cost for climbing stairs. Okay, it's a DP problem. Okay, we'll see that in a bit. So first let's read the objective. So given a staircase and the cost for each stair. Okay, so we have given a staircase and for each step there's a cost associated. Once you pay the cost at the step, you can climb one or two stairs. Okay, you are allowed to start from any of the first two stairs. Okay, so you can start from stair 1 from here or here. Your task is to reach the top of the staircase by paying the minimum cost. Okay, so let's look at the example. So let's say we have this staircase where the cost is 10, 12, 14, 20 and 7. So we'll start with any of the first two. So the first two stair, the cost is 10 and 12. Okay, so we'll take the 10 because the 10 is less than 12. Now once we are at 10, we can take two steps. We can go to 12 or we can go to 14. Right, we can go to 14. So we'll pick 14 because once we are at 12 we can go to 14 or we can go to 20, which are higher, right? So we'll go to 14 and from 14 we can go to 7 without touching the 20. So the minimum cost is 10, 14 and 7, and that's it. So the minimum cost is 31. So let's say if we start from 12, so 12 and then 20 and then top. So 12 and 20 is 12 plus 20 is equal to 32. Okay, which is greater than 31. Another example is 10, 1, 1, 15, 2, 30 and 3. Okay, so let's look at this example at our whiteboard. So this is our staircase. We need to start from here, right? And we need to reach here. So we can start from any of the first two. So we can start from 10 or we can start from 1. So definitely we can see that 1 is minimum. So we'll start from here, right? And then we can go to 1 or 15, right? And once we reach to 1 or 15, we can, after paying the cost, we can go to the next steps. So let's see how we'll solve this. So first we'll see the recursive approach. Okay, so at every step, right, at every step we have two options. We can go to first stair or second stair, right? Let's say if we are at 10, we have two options. Now we can go here or here. So we can start from 10 or we can start from 1, right? Let's say we go with 10 and then now we can go to this step or this step. So the both cost is 1, right? So let's calculate this. So let's say if we are at this one, now we can go to 15 or we can go to 2. So we can go to 15 and or we can go to 2. Let's say if we go to 15, now we go to 2 or 30. So 2 or 30. And once we are at 30, we can reach to target. We don't need to step on 3, right? So if we take this path 10, 1, 15, 30, so 10, 1, 15 and 30, so the cost is 11, 15, 26 and 56, right? So in recursive approach, we'll calculate all the possible paths, right? Calculate the cost and pick the minimum one. So for example, if we are at 1, this one, So we can go to this one and 15. So we can go to 15 or we can go to 1. Let's say we go to 1, this one. Now we can go to 15 or 2. So we can go to 15 or 2. So let's say we go to 2, and then from 2 we can go to 30 or 3. So 30 or 3, right? And then we'll reach to the target. So if we take this path, right? So the cost is 3257, right? Similarly, we'll calculate the cost for other paths as well, and we'll pick the minimum. So in this case, the minimum cost is 7, 1, and then 1, 2, and 3. Any other path would have a higher cost. So here the time complexity is pretty high because uh, as I said, at each step we have two options, right? And so the complexity would be 2 power n, right? So the complexity is pretty high. So we can reduce this complexity by solving it using dynamic programming. Okay, so dynamic programming, we know that we can solve the problem using two approaches, like one is bottom up and one is top down. Okay, so here we are going to solve it using bottom up. That means we'll start with the smallest possible problem, right? And then once we calculate that, we'll store the results so that we don't need to calculate, we don't need to solve the same problem again and again, right? For example, in recursive, once we are at 15, we can go to 2 and we can go to 3, right? So here we are solving this, and then from 15, here we are solving this. Here we are solving the same problem. We are solving the same problem again and again. So that we can optimize it by solving it once. That if you are standing at this step for which the cost is 15, we'll solve it only once and then we'll store the result, and so that we can use it in future. We don't need to calculate this again and again, right? So we'll start in the bottom up. We'll start with the smallest possible problem. So we'll we are at the start, right? And now we have two options. So first we'll create an array where we'll store the results so that we can use it in future. So we start with first two. So here the cost is 10 and the cost is 1 for this step, right? Now for reaching this step, we look at the below two steps, because remember, you can take two steps at a time, right? You can take one step or you can take two steps. So we can look at the previous two steps, pick the minimum, right? So pick the minimum. So these are the two steps. So pick the minimum, which is 1, right? Add the current cost, add the cost at the current step, so which is 1. So this one and this one becomes 2, right? So now cost to reaching this step, right? Let's say this is our final step. So cost to reaching this step is 2. Okay. Now for 15, right? So cost to reaching 15 is previous two steps. Look at the previous two steps. So this is 1, right? This is 1 and this is 2. So we'll pick the minimum, which is this 1, and add the current cost, which is 15. So 16. So now we have solved it for 15 we don't need to solve it again like this here in recursion, right? So now at this step, to reaching this step, look at the previous two steps, this one and this one, pick the minimum. So we need to pick minimum of 2 and 16, so we'll pick 2 at the current cost, right? So which is 2, so 2 plus 2 is 4, so we'll put 4 here. Similarly for 30, right? Look at the previous two steps, so 16 and 4, so pick the 4 which is minimum, right, and add 30 to it, so that is 34. Now for this step, previous two, so this 4 plus 3 7, so 7, right, and then the target. So now our array is constructed, so our final answer would be the minimum of last two, right, because either you are standing here or you are standing here, in one step you can reach to your target, right? So in this case we'll pick 7, that means you'll stand here and then you'll go to the target, so the cost is 7. So if you see, the we are doing only one traversal, right? So the time complexity is O of n, and we are using an array to store the results, so the space complexity is also O of n. This is time complexity, this is space complexity. So let's go back to our problem. Okay, so first approach is recursion. So if you look closely, each step you have two options, right? Whether you take one stair or two stairs. So we'll try out all the possible options at each stage, pick the minimum out of it. The, the problem is time complexity is very high, which is 2 power n, right? Because we have every step we have two options. And this is the recursive code for that. Mm, we are calling a min cost function, and that is calling a util. So util is our recursive function. Okay, so current is the step you are standing on, so once you reach to the final, return the cost and pay the cost at the stair, pick the minimum, right? So we are making a recursive call and solving the same problem repeatedly, right? So now this is a bottom up better approach, much better approach, dynamic programming bottom up. Okay, so you can click this link to read about dynamic programming, right? So here initialize an array, we are calling it as dp, as the same length as the cost array, right? dp of I, right, will represent the minimum cost required to reach the ith step. Okay, so like for example here, this represents the minimum cost to reach at this step, 1 2 3, this step. So and it will be calculated as the cost of the current step, right, and pick the minimum out of previous two steps, this one. So current cost plus the minimum of previous two steps, the cost. The base case would be dp of 0 is cost 0 and dp of 1 is cost 1, because remember, when you are standing here, you can go to any of these two steps. So these are the base cases. So for that you don't need to look back, because you're just starting this, there's no previous results. So 10 and 1. So let's look at the code. So min cost, this is a function, and length, and we are creating an array of the same length to store the results. And this is our base case. For the first two steps, we are just store the cost of first two steps, and then we'll do the iteration for rest of these steps. And what we'll do, pick the minimum of previous two steps and add the cost of the current step, right? So once we are done with this loop, we have constructed our array, this one, right? So now what we'll do is pick the minimum out of last two. So our result would be the minimum of uh, the last two steps. Okay, so now let's run this code. So yeah, let's run this. Yeah, so this is the same example walkthrough we have just seen, and we know that the cost is 7. So minimum cost to reach top is 7, right? So this is how we'll solve this problem. And let me refresh this page. Yeah, so now we can mark this problem as completed. And yeah, visit our website tutorialhorizon.com for more interview problems. We'll see you guys in our next video. Bye bye.